Okay, welcome to week 5 of LCC Programmable Logic Controllers 3. We're going to be talking about user-defined tags utilizing a barcode scanner. And there's a video link here that you clicked on to watch this video from the PowerPoint that was on D2L. Welcome. Once again, I'm taking attendance. I can check it up on D2L and see what's going on. I handed out new handouts, your guide sheet, your homework, your lab, and once again, there's lots of D2L reading out there about the barcode scanners that I would like you to take a look at. Let's start with our week 4 review. We certainly had some ups and downs with the working with the Stratix managed switch. I want to remind you some of the stuff that we covered and maybe learned the easy way or the hard way. The Stratix is a level 2 managed switch. It's not a full-blown level 3 router. But it does have inter VLAN routing capability, which means that we can look across networks. And we set up just a couple of networks, and we looked across them and saw the limitations of exchanging data or workarounds for exchanging data information between those. And we'll try and break that all down. The firmware update is important on these managed switches. Remember, this is a 5700. The latest and greatest is the 5800. I haven't seen it. It's supposed to be a little bit better of a user interface in that web base, but hey, we went through it pretty well. But being sure that this is updated, and you know, I was telling you that these hadn't been updated in a while, and we're like on version A or B or something, I don't know, in that or 2. And then I had to update them, and it wouldn't take the update. I had to like update one revision level at a time, and it takes a long time. You got to be patient with these when you're updating them, because I got impatient and I thought it was froze, and then I restarted it and I ended up almost bricking the switch. Fortunately, I had some switches that were working, and then I had to use the SD card to kind of save the switch, and it took a long time, so it's slow. We did our express setup to allow configuration. That's where you hold it down for 12 to 14 seconds. And what that does is it brooms the switch out. It doesn't totally factory reset it. It resets it back to the firmware level that you had just recently installed. So I had installed, you know, up to a certain point. And so this did not bring it all the way back to that old school firmware that was hard to work with. It brought it up to the current firmware that's hard to work with. So that's where we're at with that. Okay. The 5700, that's what we use. Remember, I had a 5400 switch as well. 5400 Stratix 5400 is their full-blown level 3 switch with routing capabilities. But we were working with 5700, and like I said, we may get the 5800 in here eventually. So this serves as a gateway because we set up several virtual networks, or VLANs. Originally, we set the VLAN 1 to 192.168.1-1, you know, Class C network, and all ports on the switch were on that .1 network. So we could have just plugged in, just like we've been doing, you know, plug in all our devices, and as long as the last number was different, we could have, you know, 254 devices here, and you know, it was great. But what we did is we added a second VLAN, and we assigned that to a port. Now, you could have assigned that second VLAN to more than one port and plugged in more 10 items, and then we could connect to .1 and .10 networks. And then, you know, you could have assigned .20 and .30 and .40 VLANs and ran a variety of different things. And we're going to talk about maybe the best way to do this in the future. So the subnet mask of 255.0, we didn't need to put the 0 in here because we needed to capture this octet right here. And so if we had 255, you know, just set there, we weren't going to be able to capture 1s, 10s, 20s, 30s, whatever. We're going to stuck with just with the 1s here. Okay, so we needed that to see the networks. We could not connect to like a 172 due to the gateway subnet mask, because this is a Class B trying to connect with a Class C. That would be for a different class, but basically you're thinking, well, 172 and 192, well, somehow I need the subnet. This first octet needs to be set to capture both, all of these. So then you would have to come in and you have to set your subnet here. You can't be 0 because it won't accept 0, but you have to set the subnet here and do some subnetting to figure out how to capture, both of these networks right here. Okay. If this was a 192.158 network, we could do that, but we would then have to make this 255.0.0.0. So we certainly could have, a lot of, different Class A networks with a lot of devices here that we could capture. All right. And once again, it's not, once we start changing these, is it really, it's almost looking like a Class B network, not a Class C yet, but and then we change it, then it almost starts looking like a Class C network. It would certainly provide a lot of nodes and devices that we could hook into it. But we continue to use the Class C network 190, this 192, the way that we would set up a single network, 192.168.1 is going to have 254 device or hosts. Okay. And if you need more, like I said, it's pretty common to have .1, .10, zones. If one machine's a .20 network, another machine or a cell is a .20, another cell is a .30, something like that. Okay. Other common industrial networks include, 172 for Class B and 10 dot for Class A. So depending on how big you are of a network you're looking at here, these are common industrial private networks that I see when I take a look at PLCs and automation equipment. We talk about subnetting and subnet mask, and the moral of the story here is that the USB to Ethernet adapter utilized a gateway because we needed to get into the network, and so we set our Ethernet adapter to the VLAN of the switch 192.168.1-1. That's what we made our switch was. And it's good to make this the switch a .1, and we'll talk about why it's good to make this. You can make your switch whatever you want. You can make it a 2 or 3 or 4, but it was useful to make the switch the first node there, and then your USB adapter could be .2 or .10 or .50, whatever. Okay. The subnet mask should match the network class if you hope to discover all devices. And so, as a matter of fact, if you went into here and you tried to make your subnet mask 255, 255, 255.0, we're going to capture everything on this network. We can capture those 254 nodes, but as we talked about, if you wanted to go 255, 255.0.0, then we're opening up all these 255 as well. Because the subnet mask can be used to limit your host transparency. Maybe you don't want to look at all those, but once again, that's end up being a little bit more complicated routing, but we're not going to get into there. There is lots of calculations posted on D2L for your reading pleasure if you'd like to learn more about subnetting and your subnet masks and your Class A, Class B, and Class C. All right. So let's just take a look at a couple of things that we did here. So what I got right here is a Stratic switch, and I put 5 ports on it. Ours had, I think, 10 ports, which I just threw 5 on here. And so what we did is we made a VLAN, the Stratix, and like I said, that was 192.168.1-1, and that was the switch itself. And if we do that, initially all the ports have, are on that, .1 network, and we can just plug into wherever, and we can see everything as long as the last number is different. Okay, and so you could plug in, your Ethernet adapter, and here I made my Ethernet adapter .2, and I did make the subnet 0, 0 because I want to look at these 10 networks, eventually once we get them set up. And then the gateway, that was the problem, 192.168.1-1. Well, it needs to look to the switch as the gateway because this switch is connecting to the 1.1 network and the .10 network, so that's critical. Now, let's say I wanted to add a PLC rack to my switch, so I could set my bridge, and that's what we did. We set my bridge, my local bridge, to 192.168.1.10. So boom, we're going to be able to plug right in and see it. We would set, you would probably set this gateway here and we'll talk about it whether you want it to be 0, 0, but if we just wanted to get it to work, it'd be 255, 255, 255, 0, because you know, we don't need anything fancy, but we just want to be able to have our computer here, our Ethernet adapter, see our PLC or our rack, okay? And then what we did in the past, let's say we added something like remote Ethernet IP. We got 192.168.155 for that. And then it's going to have, you know, coming out of the factory, this is going to be configured, and we'll talk about, you know, configuring this in a minute. It's going to have a gateway of 192.168.1-1. If you go to the thumb wheels to set this to 55, all right? If you set the thumb wheels to 55 or 75 or 86 or whatever, that defaults to this private network of 192.168.1, okay? And so we would be working, everything would be working here. Now, then what we did is we came and we took a couple more ports and we set them up as VLAN 2, which would be 192.168.10.1, okay? And we gave it a mask there. And these don't have gateways on them, okay? And then so in this second port, what we wanted to do was we wanted to set up a PLC. Let's throw a PLC on there. And so we take the bridge of the remote rack or whatever rack you want to call that, 192.168, gave it a 10, set the mask, and then we had to set the gateway. That was important, 192.168.10.1, which was the VLAN. Okay, so we put another PLC on there. And then we added that to links. You know, we had to add an Ethernet device and an Ethernet driver using our USB to Ethernet driver. And then on links, we could see all these .1 networks, and we could see the .10 network as well. We could see multiple PLCs. And then when we wanted to, you know, use some of the I/O or something across this, if we were programming on this PLC right here, let's say, this PLC could go and it could come in here and it could jump networks, and I could grab an input from this rack, okay? And I could use the inputs from the .1 Ethernet IP. I could use the inputs from the .1 local I/O, and I could use the inputs or the outputs from the .10 PLC on a different network. So that's kind of what we did there, okay? And then we started getting into some issues to try and figure out how, you know, how to expand this, okay? So the ELTE2R is 2 ports. It acts as a bridge, okay? And so remember, there's you know, the bridging that this switch is doing, okay? And then there's the bridging that a rack does. And so, you know, that's kind of important to think about, you know, before we get into this, what your rack does. So when you have your rack right here, let's say you have your PLC, let's say you have your eNet bridge right here, and let's say you had something like a device net card right here, okay? So this device net in this Ethernet, this is bridging the networks here on the rack so that your PLC can see the field devices and communicate with them. So there is, so this, you know, this rack does some bridging of different type of networks, device net or control net. You could put a control net card in here. And so these cards, in conjunction with the rack and the function of the PLC, could bridge that. And then the eNet here could, you know, you could get all that data and you can, you know, send it or share it to produce and consume tags or messaging or everything like that, but, you know, taking in data from here. So the Ethernet bridge, and we'll talk about this in a little bit, and even the new PLCs that have a port on them, that's even, you know, more advanced bridging that you can connect, you know, different things onto there as well, okay? So here we go. How does that work? Well, I want to add another PLC. So I got, let's say, another PLC, 192.168.10.20. And what do I want to do? Well, that PLC, could I just plug it into the second port of that EN2TR bridge? And then, it would see, then could my Ethernet adapter see my local bridge, my local PLC, and could it see the remote PLC? And could it see the second remote PLC that was ran through the bridge of the third PLC that was run through the ENet bridge of the second PLC? Well, it could. Okay. But it comes to that, like, is that okay to do? Or should we do it like we were doing over here, where we just take the second PLC and plug it into the VLAN 2 just for organizational purposes or whatever? It's not going to matter. Okay. And then the thing is, what do I got to set this, the bridge on the second PLC to? What do I set the gateway for that bridge to? Is my gateway the first? Is my gateway this bridge, or is my gateway going to be the Stratix switch? So that's where you might get into some functionality issues, because it probably needs to be 192.168. 10.1, okay, because this bridge is going to pass through, so it needs to be the 1 or the 10.1. I can just plug it into here, and then it would see it for sure. This 10.20, it would see it if I was using 10.1 directly as the gateway. And that's similar to this. Think about this remote Ethernet I/O. I plugged it into the VLAN. If I were to just plug this Ethernet remote I/O into the second port of my bridge, I would see it, and it would have a gateway of .1. It wouldn't have a gateway of .10. It's not saying, hey, I need to look to 10, and then I need to look to 1, and then I need to go to my adapter. Okay, so hopefully that makes sense. Now, what about another Stratix managed switch? Let's say we had another Stratix managed switch that we wanted to plug in to another Stratix managed switch. Now this isn't going to work very well, because if we take this Stratix managed switch and instead of being a controller here or a bridge, it's a switch with .20, and then we're going to plug that into this bridge, into this VLAN, trying to get to our computer, and then this Stratix managed switch is going to have its own devices all plugged into it. Well, then the gateway doesn't work like it should be. Then you start saying, okay, so my new Stratix switch is reaching out to the internet, and once again, all the devices here, you're thinking, well, the devices here have to have a gateway of 10.20 on them, and then that 10.20's got to see the 10.10, and then that 10.10's got to see the 10.1. Yeah, it doesn't work. Okay, if you're going to do this, what you would probably do is, coming out of these different VLANs, you could set 10.20, 10.30, 10.40, set those to, just send those to unmanaged switches, if you have a bunch of devices, okay? And those unmanaged switches will bring, all that data back to here, 254 per network devices. And if you need more devices, make a 10.30 network and put it on it. So at this point, you're probably not going to connect a managed switch to a managed switch to a managed switch. You're probably going to have a managed switch going to unmanaged to unmanaged to unmanaged. Now, you do need to do the managed switches to a managed switch to managed switch. You're starting to look at, routing issues and all this kind of stuff, and we're not going to get into that in this class, but you could do, you can start doing some of this with a level 3 switch. So that's a lot of talking here about this. Hopefully the gateways and the ability to connect is making sense. And also the ability to do backplane bridging, backplane bridging there. So the other thing that I wanted to talk about was the 5581 ES. And once again, that has 2 Ethernet ports on it, or so it has 1 Ethernet port. This bridge has 2 Ethernet ports. So we were just using this to bridge the same network. We could, if this was a .1 network, we could put .1 devices into here, and then .1 devices into here, and it just sees them. This 5581 ES right here, it can be set with its own IP address. It can be set, with like a .10 network or whatever. Remember, this Ethernet bridge right here, that's what's connected to the backplane, and that lets me see all these devices. Even though this right here has a .10 on it, it's still seeing the 5581 ES, okay? Now, what you can do is you can get rid of this Ethernet bridge right here, and you can just, let's say this was a .1, you could just plug your Ethernet adapter into there, and then you can, at that point, see the backplane, program it, dump it, make connections and everything like that. If you want to add your Ethernet bridge back here, then you can plug other devices in, your managed switches and everything into here to expand your rack, okay? But the interesting thing is that this 5581, is a little more advanced, and it can do a little bit more, I guess, routing or bridging across different networks. But we didn't fully get into that. We got into using a managed switch with inter VLAN routing to do that, instead of having, the 5581S in conjunction with the ENET, in conjunction with your backplane bridging to accomplish that. But, we just kind of wanted to give you an idea, that you can do different networks and that you can work with them. Now, a couple of other notes real quick. When you get these devices, you, from Allen Bradley, you can set them using thumb wheels or rotary switches. For example, here's our remote adapter, and it's set to 999 out of the box. This is the EN2TR switch, or ERT2, and there's little rotary switches here that can be set. Okay, so you're probably going to get these, and they could be set to 999 coming out. And what that means is that you can then configure them to whatever IP address you want. If you instead set this 999 to, let's say, 55, okay, well that defaults it to the private network 192.168.1, and then whatever number you put here, it'd be 55. It'd be a 192.168.155 device. And the other thing is, at that point, it defaults the gateway to 192.168.1-1. Now, that's where I was trying to tell you here that when you do this managed switch, if you make this managed switch a .1, that's good, because then it's going to see the gateway as the managed switch, and that boom, this remote Ethernet is going to work right away because it gets defaulted to 1. If for some reason, like I said, you wanted to make it a different, like a 172 network, you could set this to 999, and then you could set the IP address of it. Now, the problem with this remote Ethernet, it does not have the USB A to B connector. So you have to, at 999, it's going to be DHCP. You got to go into boot P, and then you got to set up your IP that way, okay? And then you cycle it, and it will keep it as long as it's set to 999 here. You change this to a number, boom, it's going to change it back to a 192.168.1 network. The Ethernet bridge is the same way. It's a little bit easier because it does have a USB on it. So if you set this to 999, you could go in there and see it, and then you could make some changes to it to give it the static IP address if you wanted a 10 dot network or a 172 network or whatever like that. 888, if you set those to 888, it is a factory reset after the power cycle. So that's the way some of these Allen Bradley devices work. Homework review. There was lots of internal material that I posted, especially that documents, that calculations one was great. And so homework was pretty good. Wanted to reiterate that the TCP/IP networking model is more practical than the OSI model. That's very theoretical, and the TCP/IP kind of sums things up almost to what you can see. The big chunk of that is the physical. Kind of looks at the physical. What am I hooking up? What are my devices? What are my cables? To help you kind of understand how things are being compacted. We talked about messaging is a way to send information across different networks, and messaging is explicit, right? Which means it's going to be It's going to be some timing there. Produce and consume tags do not send information across different networks, and it is implicit. It just pounds that information out. It'd be like synchronous versus asynchronous, I guess, a little bit if you're thinking way back to COM. So we talked last time about the difference between explicit and implicit messaging, or explicit and implicit sharing information. But once again, messaging will be your explicit, because produce and consume tags cannot reach across the networks. A couple of other things. Panel view setup. This is interesting. We had one of the students messing with this. When you set up your panel view, you can set up two network passes to two different network passes. When you run your link setup, your factory truck link setup, you can install two connections pass-throughs to PLC racks on different networks. And then when you click copy to runtime, it will allow the PLC to show the status of two different PLC programs on the same screen. So think about that. You can have a button on the screen running through the network pass to PLC 1, and then you have another button running through the network pass to PLC 2. So the panel view will indicate what's going on with two PLCs at once, even though they're not interconnected. And that's what I'm saying. Just because the HMI can monitor the two different processes at once, two separate PLCs on two separate racks on a single PLC, that doesn't mean that the two different processes can actually monitor each other. So those PLCs don't see that. If you want to monitor each other, if you're on the same network, you could use produce and consumed or messaging. But if you're on different networks, which once again, the HMI could monitor two PLCs on running different processes on different networks, okay? But if you wanted to have the PLCs talk to each other, you would use messaging over the networks. Quiz review. So that was the safety relay setup. We did a little bit of this. Everybody's doing pretty good on this. Just want to reiterate one time the safety relay here. I just got line 1, line 2, whether it's an AC or a DC relay. It's just like it's got a dual channel E-stop here. It could have multiple other E-stops or safety circuits or safety gates, but it just said do a E-stop, and I've got the dotted line around there to indicate it. It's got a manual reset here. And then here's my motor. It's just turning on a single contactor to turn on the motor there. Notice that I am monitoring the status of the contactor. Here's my monitoring circuit here. That's what it wanted to do. It said monitor the status of the contactor. I'm turning on a contactor, and I'm giving a signal to the PLC. The PLC tag is called SR. Okay, so if this is up, I have the opportunity to turn on the contactor if that's what I want to do. But if it's off, it doesn't matter if the PLC turns on the contactor or not. I will not get voltage here. And same thing, if this is on, I'm getting a signal to the PLC that seems something's, I can go ahead. And if it's off, then the PLC will know that the safety relay is down. Okay. And so my program, once again, assuming all my inputs are mapped here, because I did a make break versus break make. We've talked about the issues with doing it this way, but I did it kind of the old school jog button, start button. You could have did it with a selector switch or a start. I mean, there's a few different ways that you could do this with a bit, 2 rungs. I mean, however you want to do it. I accepted the different ones for the quiz, but I kind of did the old school way here. We had a stop button that would have been, where it normally closed. Remember, this is not the E-stop. It's just a stop, a normally closed stop. If I hit the stop button, that in no way affects the safety relay. That's just the stop for the program. And then I had the start button. That's the safety relay here. Contact we needed to when the safety relays reset, well, then that's going to close. And then I just did my memory here, and I had my jog button here, opening and closing. Remember the make break versus break make. Input mapping becoming critical for this to work like we want it to work, right? And then the other thing you could do, you just could take the safety relay here and add a system instead. So instead of making this the safety relay, you would make this the system light, okay? And then the system light would consist of the safety relay, which would be closed. And now we're adding the overloads in here because it asked to be monitoring that as well. The overloads are closed. I got system on, system off. So this might be, you know, your start the system, stop the system. And this stop the system, once again, would be like a normally closed push button. And this would be like a normally open push button. So I would come and hit the system on, I would get the system light, it would give me memory. And then right here, I would have instead system light here. And then I would have true there. And so if for some reason I brought the system down, either by a loss of power, by hitting the system off button, hitting the overload, having the safety relay go down, any one of those items right here would bring the system down instead of just a safety relay, at which point it would kill the contactor. So that was kind of what I was looking for the quiz. And as I go over this, hopefully it all makes sense. You know, there's different ways to do this, but you know, this is you're going to see this kind of standard that you'll see, you know, this version of this quite a bit. All right, so hopefully that made sense to you. This week we're talking about part tracking. We're going to be using a barcode scanner because, you know, barcode scanners are utilized. I put a document on the D2L. Talk about part tracking, but we're going to use a barcode scanner for part tracking. The document that I have there is Allen Bradley product tracking on D2L, and it talks about the different ways to track parts, and that's bit shift. And we'll just revisit. We're not going to totally revisit bit shift. We don't have to program that. What we're going to do first in, first out, and then we're going to use user-defined tags. So when you start looking at that document, I'd like you to read it. It talks about the first way to track parts, and that's just a bit shift left or bit shift right. Here's the bit shifting right. And a lot of times they just use this when you have a word to indicate if there's a part there or not. You know, if there's a 1 here, you know, in the first station, and there's a 1 here in the third station, and a 1 here in the fourth station, and a 1 here in the 7th station, and the 8th station. You know, these ones can indicate whether there's a part there, or those ones could indicate whether that part was painted, or that part passed inspection or failed inspection. And then as the next part moves down the conveyor system, you could shift this left or right to just, you know, indicate that, you know, these parts are just moving down the line. And then when they get to a certain station, you know, if there's a 1 or a 0 there, does it need to be repainted, or does it need to be, can it pass through? Or if there's a 1 there, does it need to be put on a diverter somewhere to go down a different conveyor or whatever? So we went over this extensively, bit shift left and bit shift right, and the document would indicate, you know, if you read that document, of how to do of how to use that. The document next talked about first in, first out, and what we did there was we were then taking some more information about the product. Let's say instead of just a 1 or 0, meaning that it was there or not, that's what that one did. The FIFO could actually take some information about the item. Let's say it was a number, like the first part coming down was a 50, and the next, for some reason, the next part coming down was a 76, and the next part coming down was a 23. And the next part coming down was a 58, whatever it's measuring, or whatever that number indicates. And then we would stack those numbers up, and we would be able to keep track of them, so that we wanted to look at, hey, what was part number 4 again? What was the tolerance, or what was the size of part 4 again? And we measured, and you could go back and say, oh, that was 58, okay? Or part, the other part was, you know, 23. So it talked about stacking up and unstacking more information about parts as they come down the line, okay? And then at the end, it talks about using user-defined tags, okay? And so a user-defined tag can even have more information, okay? And so what you do with a user-defined tag is you make a tag name, which becomes the type of data. And so the type of data that we've had in the past are real numbers or integers or booleans or whatever. Well, what we do is we just package them all up and give that a name. And that name becomes the new data type because it has a variety of different things. And so now when a part comes down, we can keep track of a lot of things on that part. We, if we're measuring something, we could throw that in here. The part number, we could throw that in here. Is it there or not? We could put that Boolean back in with the 1 and the 0. We could put it there. You could, whatever you want to do with that part, all the different variables, you could put it in here, and then store it like in a FIFO. And then the next part that comes down, the same number, the same tag number, the same tag name, it might have different values for all these items, and boom, we could store it. And the next part comes down, and it would have different values again, and we could store that and stack it up. So that's what the lab is doing. And you can take a look at the lab and read that document. Excuse me, and it'll tell you, a little bit about user-defined tag. So we'll be creating this a little user-defined tag using the HMI, and then we're going to use the barcode scanner to load some data into that user-defined tag. Because that's what you might see on, you might see that when a car is coming down, you put the tire on it. You might hit a scan, so you know that Joey was the one who put the tire on. Hit the barcode scan again, or maybe it's recording the time that Joey put that on. And then you might torque it on, and when it gets torqued, it will send the value of the torque set, to be sure that the value is right. And it would, as it went down, these scanners and information would load all this into this user-defined, and it would roll down. And then later on, when the tire falls off after you sold the car, they say, wow, why that tire fall off? Well, you can go back to the data and say, oh, Joey did it at on 4th of July, and he didn't torque it down enough. The torque setting wasn't right. So whether you use a PLC to do this, you're going to probably use some other, larger database program to store it all. But hey, they have all that data. Okay, maybe just an example. I'm sure you can imagine other things that you could store all this data. Okay, read the barcode basics on D2L. It's just pretty basic. Some basic reading. Take a look at it. We just be kind of quiz on this information about the fundamentals and uses, the types, your dimension cells, your decoding, the hardware required. So I'm not going to break into all this barcode basics on this lecture. It's really not that much to know, just the philosophy of how it works, and that's in your barcode basics. And what are you using scanning for? One thing would be like recipes or scheduling. When a part comes down the conveyor, if it scans the barcode, it could pull up a certain PLC program, and then that part could receive that operation and then move on. The next one coming down might have a different barcode, at which point it might get a different program, different timers, different counters, different processes done on it. So scheduling it could be used for. Inventory tracking, we just talked about that. That'd be a good way to keep track of stuff. And putting manufacturing timestamps on when everything was made, so they can track quality control. And that says product quality. You could track pressure settings, temperature settings, torque gun settings, which employee was working that day, just anything that might affect the product quality. You could probably track it. And then you could also use all this to just check the cell operation, the throughput, to be sure that everything is coming through, and let the autonomous system kind of troubleshoot itself. All right. So you're going to be doing a scanner setup. The item will be read by the Logic software. We have a Cognex scanner that we'll start with, and then you're going to have to set up the add-on profile and the EDS files for this. Okay, and so you're going to do all this from scratch. We'll talk about it. It might take a while. I don't care how long it takes to set it up. Just set it up, kind get familiar with equipment. It's kind of fun to hook up some of these things. So we'll start with the add-on profile. An Allen Bradley add-on profile is a component for Logix that provides information for the PLC to recognize and configure the device, okay? Since a drive vision system, whatever. AOPs offer a user-friendly graphical interface. So that's when you have the AOP, if you have the correct one in. When you plug in your Cognex scanner, boom, all of a sudden it knows that it's a Cognex scanner. It won't give you that, that yellow question mark, okay? And it will automatically bring in the tags automatically and monitor live data. So, for example, if you were to plug in an Allen Bradley input card into an Allen Bradley rack, you get all the controller tags for it. It knows an Allen Bradley rack knows an Allen Bradley input card, and therefore all the global tags are created. Well, if you have the right add-on profile and you add a scanner, boom, all the controller tags related to that scanner are automatically created. You could create them all from scratch if you wanted to, and that's a whole different deal, but you need this so that the software can understand the data and everything that's coming in. It just simplifies the device integration, and you don't need the need for manual messaging instructions and separate software to try and get all these things talking to each other. And this just goes back to what we've been talking about for years, that you just had like an old school RS-232 DB9 and you wanted to hook up a scanner. Well, you might need the scanner software and then the PLC software. Then you need a bus or a translator and do messaging to get all this to come in. Nope. If this is a reputable device, it's going to have an add-on profile. You add it, and bang, you're going to be looking good. So the newer installations of Studio 5000, we have the latest version 37, and that they include more add-on profile information than prior versions, okay? And so if you're adding a device from a popular manufacturer, it might be included in the software already. If it isn't, you have to install it manually from the manufacturer's website, which isn't a big deal. There's so many devices out there that you might want to see, that you can just reach out to the manufacturer and get the AOP for it, okay? And so once again, this is what we talked about. It'll automatically configure it for you. Automatic tags are created, and you can look at the user-defined tags and see what they are. It allows you to monitor and integrated program. It's direct connections and calibrations through the Studio 5000. So Studio 5000 will be the software that you can use to interact with this thing, okay? So that is going to be what we're doing there. Now the EDS file stands for electronic data sheet. It describes the characteristics of the device for the network configuration, like RS links, okay? So these files allow the software to identify this device and understand the communication parameters, okay? And so if you have the EDS file, and you get these add-on profiles and these EDS files all set up and everything. The beauty is when you go to RS links and you get everything set and you go RS2, if you have like a scanner, a barcode scanner on RS links, boom, like a picture of a barcode scanner pops up, just like when we do a PowerFlex drive. When we do that, a picture of a VFD pops up, or a picture of a robot would pop up, or whatever, if you had all this stuff configured as it should be. If not, you can still use it. You're just going to have a question mark and says, hey, there's something plugged into me. I don't know what it is. I don't know anything about it. But you're not going to have quite as much functionality as you would if you have these items, okay? So it may be necessary to download the EDS file from your manufacturer if the current revision level of your software does not recognize the device. And that's a vendor ID and parameters IL structure, right? And once again, the primary purpose is to facilitate communication between the device and the control system. And so you're going to have to do this. You're going to have to download these EDS and AOI, right? And here's the screen once again. The difference between them and an add-on profile is the EDS file is defined by the field device manufacturer, while the AO profile is downloaded from the PLC manufacturer's website. So you have to reach out and take a look at these. And when you get it all set up, you'll see that links and logics see everything. They have the tags, they see the communications, and everything, works good. So take a look at these slides here, and be sure you understand, and the lab will make sense, because it'll definitely be something that we're being quizzed on. I want to talk a little bit about power over Ethernet. So this is a technology that allows a single Ethernet cable to transmit both power and data to network devices, PoE. All right, now this is good and bad. This can get you in trouble because you can have power coming over your cable, and your device might not want it. And so that was something I was talking about with the old 503 processors. If you plug the power over Ethernet into a 503 controller, just because it's got an RJ45 on the end of it, you're going to blow that controller up, because that's a serial communication. So you want to be sure that if you're power over Ethernet, which is what we're doing, you want to be sure that you're plugging this into the right port. So don't be plugging anything in until you verify it with me, to be sure that we're not going to blow anything up. So what this does, power over Ethernet, eliminates the need for separate power supplies and outlets, making it easier and more efficient to install networks. So when you talk about power over Ethernet, as you would expect, here's Ethernet IEEE 802, right? That's your Ethernet standards. And there's a lot of Ethernet standards that talk about this. And in power over Ethernet, 48 volts DC is common. It's not going to be AC volts, it's going to be DC. It could be anywhere from 44 to 57, whether you're talking about high or not. But, we're talking 48 volts is kind of where we're at. How come? Because that's below a threshold of 50 volts. Once you get to 50 volts, are you going to get some arcing? Or are you going to get enough potential there to do some damage to somebody that's touching it or something? But under 50 volts DC is relatively safe. It has limitations on wattage. Okay, PoE plus is up to 30 watts, and high power PoE up to 90 watts. Okay, so yeah, it's definitely not like heavy duty AC wiring, but the way that things run these days with solid state electronics, you don't need super high voltage and super high power consumption for some of these devices. Somewhat related, remember that USB provides power as well. It provides 5 volts DC. Okay, although once again, not a lot of amperage, but you use USB to charge your phone and all this kind of stuff, so it does have power over the cable. The convex cameras do utilize power over Ethernet. They're very expensive. I want to be sure that you're careful hooking everything up there. So your power over Ethernet techniques, you'll see things like your phantom power uses the same 2 and 4 signal pairs that. And there's alternate B, which separates the data and power conductors. And then there's 4PP, which uses all 4 twisted pairs parallel, increasing achievable power. So depending on how much power over Ethernet you want, these are some of the things that you have to talk about. Phantom power. DC electric power is applied to both signal wires in balanced cable. So assuming that your connection is balanced, and let's say 2-wire, you create a signal that carries on the active electronic circuitry. Now, I got these power line adapters showing here. This is what I use in my house. I plug my Ethernet into one of these, okay, and then this gets signed an IP address, and then I plug it into the wall, and then it uses the AC wire, the conductors for the AC in my house, 120 VAC. It uses that to reach this one, which is plugged in the wall with an IP address. Okay, and then these two things communicate each other over the AC wires, and then I plug my devices into here. So that's how I transmit Ethernet in my house, instead of tearing out the walls and putting Cat5 cable through all the houses and everything like that. I just use Ethernet over power, and it kind of works one way or the other. So spare pair is what we're talking about between A and B. Okay, spare pair sends power over the same wire pairs that carry the data. So there you have your data coming down, but the the data is also carrying the power, and the way that how it works, power is applied to the center taps of the transformer on the data pairs. The technique keeps the low frequency DC power from interfering with a high frequency AC data signals. So you got that the DC AC, okay, and you can go ahead and read this about why it's versatile, works for all Ethernet speeds. Okay, alternative A. Versus spare pair, which is easier for troubleshooting for sure, uses the unused spare wire pairs 4, 5, and 7, 8 on your Cat 5 cable to deliver power, leaving the data pairs free. So your data pairs are doing data, and then this is doing power. Okay, and the voltage is directly applied to the spare pairs, so you just keep your voltages separate. And so once again, you can kind of come through here and take a look at it, and I think you can see that the separate power data would be easier to troubleshoot because you're either troubleshooting the DC, your signal coming through, or if your power isn't working, you can just directly go to the pairs to look for your power there. So definitely easier troubleshooting, and then you can get more power there. This uses all 4 twisted pairs in parallel. You can get higher voltages. And so, that's what I was talking about, where you can get up to 90 watts. So if you need some of this equipment, this is some of the things that you could dig into and educate yourself about how this works, and pick appropriate devices. All right, but a lot of times you're just going to be using phantom power, alternative A, okay, or just your separate share pair. And I think that what we're using is we're using share pair for the Cognex. All right. So we're going to be commissioning some new equipment. We have our Cognex devices. We have just a handheld barcode scanner, and then we have another a barcode scanner that would typically mount on the side of a conveyor or something like that. And we use USB or Ethernet dynamic host protocol to assign a static IP address. We're going to go through and set that up. Also, before you do that, you got to assemble all these things. You got to go to the AB download center, get your AOI, go to manufacturer, get your EDS, your manufacturing software installation. So you're going to have to download the Cognex Dataman software, the latest and greatest. You can download Dataman, and it's going to bring stuff in. You have to download your like I said, the information that you want on this Dataman download. There's really small screws involved as we start putting some of this vision system equipment together. So I'll have some tools we want to be careful, take our time, set this up. And we just want to be careful with all these scanners and all this vision equipment as we start putting together and then getting them ready. And we want to be sure that we're running the power over Ethernet to the right ports and the right power supplies into the PLC, because we don't want to blow anything up. So this may be just, I don't know, it's going to be a slow go. It's going to be kind of fun setting up some of this equipment and then getting it going. The lab has got a lot of extensive reading on it, and so you just want to carefully go through it, and it should be fun. All right, so it's quiz and lab. I will open up the quiz, and you'll have the normal time to get it done.